So in this presentation, I want to highlight 2 points. First of all, this is a Science for Alaska series, so I want to emphasize that this is a story about Alaska. It is focused on Sitka, and it's talking specifically about a volcano near Sitka that's shown on this slide. The volcano is Mount Edgecumbe. At the beginning of the story that I'm telling you, Mount Edgecumbe was considered to be a dormant volcano sitting sort of off the shore of Sitka here in the location shown on a map. So the first part of the story is it's going to be an Alaskan story. The other thing that I want to talk to you about is that this story is a story about community. And I want to convince you in this talk that if we work together as teams, I want to convince you that we can achieve science better and we can achieve science faster. And in this particular story, I want to talk, I have 4 different groups that are involved in this. We have Alaskans all around the state that contributed to the story. And then we have 3 units at the GI that have participated. Us, the Alaska Satellite Facility, we are providing remote sensing observations across the state. Additionally, the Volcano Observatory and the Alaska Earthquake Center, responsible for monitoring earthquakes and seismic activities and volcanoes across the state. Very Alaska-focused organizations. So I don't know where I have to point to get this to move forward. So the protagonist of our story is Mount Edgecumbe. This is a beautiful photograph of Edgecumbe. You can see the caldera very nicely, the crater very nicely. Edgecumbe, until the beginning of the story, was sort of the red-headed stepchild of volcanoes in Alaska. Like Nettie. We're sitting over there, so if you want to know what a red-headed chipstart looks like. And it was because it hasn't had any activity in the last, say, 1,000 years. It was considered dormant. It was not instrumented and was really not on anybody's radar of that group of cast of characters that we'll talk about. Really, the main activity that happened at Edgecumbe in the recent years was a April Fool's prank that was played by a citizen of Sitka who in 1974 took 50 vehicle tires and some fuel up the mountain and lit them on fire to pretend that the volcano was erupting. It was the biggest story of Edgecumbe in the last 100 years or so. It made the news in Alaska, was a big thing in Sitka, but also made news all around the world. So the story that I'm going to tell begins on April 11th of 2022, so less than a year ago. And it starts with a person in Sitka. So somebody in Sitka got up in the morning, they whipped out their cell phone, and they found, navigated to the Alaska Earthquake Center page, and they found that there was an earthquake right centered on Edgecumbe. And they got really curious about that. So they ended up calling up the Alaska Earthquake Center and asked the question whether that earthquake may be related to the volcano. And so the Earthquake Center then got active. They are in charge of monitoring all the earthquakes in the region. Do we have anybody from AEC in the room? Nobody here today? So when they looked at the archive, they found lots of earthquakes here that aligned with the seismic activity as expected, but they saw this swarm of earthquakes right under Edgecumbe. So you see here, thousands of earthquakes that happened in early 2022. And they got really intrigued. They dug more into the archive. They found more earthquake swarms also in 2018. And they really started to get curious what's behind this story. And there might be more to Edgecumbe than they were thinking. So this made the news really quickly. Within just a few days, it showed up in the Alaska News, not the Newsminer, the Alaska Daily News. And clearly this was an important subject for Alaska. So the Earthquake Center on the 14th then reached out to, where's the computer? Okay, reached out to the Volcano Observatory, and a group of graduate students, fantastic graduate students there, got active, and they reached out to us at the Alaska Satellite Facility. So if you don't know too much about ASF, ASF is NASA's data center for SAR, or synthetic aperture radar data. These are cloud-free, weather-independent observations that can monitor Alaska and Alaska's hazards 24/7. So a very important data set for Alaska. Also, I want to say we are one of the largest data centers in the world, located right here on campus. We currently have about 15 petabytes of data in the archive. And if that doesn't mean anything to you, that's the equivalent of about 165,000 4K movies. So if you wanted to digest all of our data sets in the form of videos, it would take you more than 40 years of nonstop watching to get through it. So in other words, it's lots of data. But what's interesting about our data set is that the data sets have the ability of measuring surface displacement with very high accuracy, motion that often relates to earthquakes and volcanoes as they unfold. And so we create this estimate of motion using interferometry. We create interferograms. These are these sort of tie-dye looking images that you see on the screen. And you don't need to know too much about them, but what I want to point out is the places in the interferograms where you see all these different colors, that's where stuff is happening. And we can use that really effectively to look at volcanoes. And so if we look at volcanoes and volcanoes are inflating, we get these very nice circular structures in these interferograms. So I want you to memorize those. So the students then started creating some of these interferograms. And one of the first ones that they found is shown on this slide. And when we zoom in on Edgecombe, you see right away that you have these very nice circular structures at Edgecombe, very clearly indicating that Edgecombe is inflating. This was a remarkable sight. This volcano has not been erupting in like 2 to 4,000 years. So it clearly indicated that something's happening at Edgecombe. So they started working with ASF and digging into the data. And because of the capabilities we have here on campus in the form of cloud computing and big data processing, they were able within less than 24 hours to create more than 1,500 data points through interferometry and put them together. And they got this estimate of surface deformation that you see here. The red thing here is showing uplift. So that's where most of the uplift is happening. And if you look at the scale, Edgecombe since 2018 has uplifted by about 25 centimeters, which is quite a bit. So also they could not only look at the average total deformation, they could look at the time series of deformation and see directly how the event unfolded. And it's very intriguing when you look. You see here, everything started uplifting in 2018, which is coincidentally exactly the same time when the earthquake swarms at Edgecombe happened as well. So all the data points came together, and it's clear that there is magma intrusion happening at Edgecombe, and Edgecombe is not considered dormant anymore since this study. Now, since then, a few things have happened. Just a few days later, there was a press release by AVO indicating these findings and indicating that there is magma intrusion. And then less than 1 month after the event, so on April 11th is the first time we heard about this, and less than 1 month later, all of these teams worked together to submit a scientific paper, which since has been published in the Geophysical Research Letter. So very rapid progression from initial indication to the final scientific publication. And it was made possible by collaboration between all the different teams. Also, since then, what happened? Edgecombe is now not a red-headed stepchild anymore, Nettie. It since then has been instrumented and is now continuously observed by the Alaska Volcano Observatory. Also, AVO went back to the community to bring the story all the way back to Alaskans and have done community events to inform the community of the ongoing activity and the measures that AVO has taken. So coming back to my premise, in the beginning of the story, I said my premise is that if we all work together, we can achieve scientific results quicker, and we can achieve better scientific progress. And I think hopefully this story shows this to you. And so I want to end up with saying, like, if we all work together, we can't only do science for Alaska, we can actually do science with Alaska. And with that, I end for questions.